We are now going to take a look at an example. We're actually going to do example 10. You're going to come back and do example 9 in the quiz just to make sure that we're understanding. So notice it says in example 10, given the ratio for cosine of theta, find the remaining ratios. So right here is where we have cosine of theta. Now, what we're going to start by doing is drawing our triangle, marking our theta, and then cosine is opposite over hypotenuse. No, sorry, cosine is adjacent over hypotenuse, so I'm going to fill in that 2 and 3. So my theta is this angle that I've marked. That's my theta. And then my adjacent, the one that's touching it, is 2. My hypotenuse is 3. That's our definition of cosine. Now, notice before I can find other things other than secant, I'm just going to flip-flop it. Before I can find anything else, I need to find my missing side. I'm going to use the Pythagorean theorem to do that. So I'll call that side B for no particular reason. Actually, you know what? I should call it A because I think we used A as the opposite, but it really doesn't matter. So I get 4 plus A squared equals 9. So A squared equals 5. So A equals the square root of 5. Notice I'm not doing the plus or minus because we're doing distances here, and distance can't be negative. So normally I'd say, you took the square root of both sides of an equation. You must use plus or minus, but I don't need that here. So square root of 5 there. Now, we're going to use this. Sorry. There we go. We're going to use this to find sine, cosecant, tangent, cotangent. So for sine, I'm going to do opposite, which is your square root of 5. Over hypotenuse, which is 3. And then for cosecant, I could go back to my definition, or I could just do the reciprocal. That's why they're called the reciprocal ratios. Now here's the problem with my cosecant. I don't like that square root in the denominator. So I need to rationalize my denominator by multiplying top and bottom by the square root of 5. Remember what I'm doing there is I don't like radicals in my denominator. So 3 square roots of 5 over 5. So the first answer, 3 over the square root of 5, is correct, but it's not pretty. 3 square roots of 5 over 5 is equivalent, and it follows our rational rules. No radicals in the denominator of a fraction. Then we have tangent. Tangent is going to be opposite over adjacent, so square root of 5 over 2. And then cotangent is going to be the reciprocal of that. And again, rationalizing that denominator. So 2 square roots of 5 over 5. And there you have your 6 trig functions for this triangle. Now notice what you're going to do now is you're actually going to do number 9 in the quiz. And notice that I've given you the opposite and the adjacent. You'll need to use the Pythagorean theorem to find your hypotenuse. You're going to get a rational number there. You're going to get a nice pretty whole number, not square root of 5. You're going to get 23. It's not going to be 23 because it's going to be bigger than 30, but you're going to get an actual integer here. And then you're going to type in your 6 trig functions.